piece of magnesium ribbon is reacted with hydrochloric acid. If 224 milliliters of hydrogen gas is produced at 25.0 degrees Celsius, 1.00 atmospheres, how much HCl was consumed? The balanced equation for this reaction is Mg solid plus 2HCl aqueous yields MgCl2 aqueous plus hydrogen gas. The amounts of reactants and products that are consumed and or produced in a reaction are directly proportional. This means that the mole-to-mole ratio of any pair of substances involved in a reaction is constant, and the constant is simply equal to the ratio of their coefficients in the balanced equation. In other words, if substances 1 and 2 are involved in a reaction, the ratio of moles of substance 1, shown here as N1, the moles of substance 2, shown here as N2, is equal to the ratio of the coefficient of substance 1, C1, to the coefficient of substance 2, C2. If we happen to know N2, we can rearrange this equation to solve for N1. N1 is obtained by multiplying the known moles, N2, by the ratio of coefficients, C1 over C2. In other words, the ratio of coefficients serves as a conversion factor. In this problem, we have enough information to determine the moles of hydrogen gas produced. So we let N2 be equal to the moles of hydrogen gas. We assume that the gas is behaving ideally and use the ideal gas equation to solve for the moles of hydrogen. The number of moles of hydrogen, N2, is equal to the pressure times the volume divided by the gas constant R and the absolute temperature T. The pressure is 1.00 atmospheres. The volume is 0.224 liters. Note that it is given as 224 milliliters in the problem. We convert the volume to liters so that we have unit consistency with the value of R that is typically given on tests. R is equal to 0.08206 liter atmosphere per mole per Kelvin. Finally, the temperature is given as 25.00 degrees Celsius. But we must commit to Kelvin. 25.00 degrees Celsius is equivalent to 298.15 Kelvin. Carrying out the indicated calculation gives us 0.009155 moles of hydrogen. All we have to do now is multiply this by the ratio of coefficients. Since we are being asked for the moles of HCl, our conversion factor will have the coefficient of HCl in the numerator and that of hydrogen in the denominator. The coefficient of HCl is 2. The coefficient of H2 is implied to be 1. In other words, the balanced equation tells us that 2 moles of HCl are consumed for every 1 mole of hydrogen that is produced. Carrying out the indicated calculation gives us the answer to the question. 0.0183 moles of HCl are consumed.